3. Oh snap, it's going up. So wait a few, crossing my fingers for 4, maybe 5. I don't know, maybe that's a little hopeful. Probably a little hopeful. We're already past my usual for a last day. Yeah, I thought I needed something appropriate. Quit, you figure it out. All right, the drink of professionals. Specifically, Baja Point Break Punch. Tropical punch, it'll do. For the record, before I came in here, found the door closed, tried to wiggle the handle, it didn't open, called security. Like, did you try pulling on it? Pulled on it and it opened. Like, all right. Guess I should try that. I don't expect the door to open if the handle doesn't move. I don't know. Maybe that's, I don't know. Maybe that's me.
You know, the door you first go into when I get into work, it's one of those doors like that you just pull on it. So now at work, I'm constantly pulling on doors that have like an active door handle.
There's one door at my work that was broken for a little while, and it's one we have to use a key code to get through. So it's probably really bad that it was broken, but we were just like pushing through it. And then they fixed it. And then all of a sudden people were walking into the door. It was beautiful. Exactly how the world should be. Hello.
I just wanted to drop off some letters.
Yeah, do it.
All right.
I'm excited. I was just delaying the start of the class in hopes that I get more than 3.
Yeah. Are
You
you
know,
having anybody connect online too, or?
nobody has this entire class.
Oh,
Not
lovely.
once.
Okay, great.
Yeah,
Well,
that's the
that's
first
good to
time that's ever happened. I usually have like 2 consistent online.
right. Interesting. Okay, well, good to know.
You know,
Yeah. Yeah, we'll see if more come, but good job, guys, for coming. That's good.
I'm pretty happy about that. Yeah.
Yeah. So, so I'm the AB, I don't know, I know that you and I have already met. I don't know if you've seen me yet, but I've been coming to the classes, and so my name's Daisy. I'm the new AB program coordinator. So I'll be helping you throughout the classes. I'm sure you'll be hearing from me, communications, things like that. So I just wanted to try to meet everybody. And I also just want to say, I am sending emails with your current hours. So, hours from the last time you took your assessment to figure out what your level is. We try to get you to hit 50 hours so then you can take another progress assessment. And that's really important so we can figure out where you're at. And then we can make sure we're placing you and giving you the right instruction. It also helps our program and it helps keep our classes free. That's kind of like your payment for our classes, is making sure you're attending and taking the progress assessment. It really helps us. So just wanted to let you guys know, I'll be sending out emails and things like that. So definitely respond. And then if you need to make up hours, you have until June 12th. And so you can do essential ed, Aztec, whichever one you like better. But just remember, it's all to help you out and what your goal is. So, so these flyers that I brought, I know you already got one yesterday. It's for the automotive. It's an automotive certificate. And so you can take it while you're still in the process of getting your HSE. Yeah, and so, all you need is to be, level 4 or higher in, your reading and writing. So that's another reason why it's important to get those progress assessments in, because if you're teeter-tottering on, getting a level gain, if you're like a level 3 or something in one of your subjects, it's good to get that assessment in.
And if you already passed the subject.
And so if you're already higher,
Yeah, I only have the math.
oh, you only have, okay, did you take GED or high set? High set, okay. So definitely, I'm gonna give you the flyers and just go ahead and reach out to, it's Samantha. She's at the Career Pathway Specialist, and she will give you all the answers that you need. I believe she did let me know that the dates that are on here, they may change. But it still should start roughly in August. I just think the days of the week. Tuesdays and Thursdays, it might change to Monday, Wednesday. But she'll let you know. So yeah, definitely reach out. I'll leave a couple in case more students come.
I don't know about that.
Right, yeah. Well, maybe I'll just leave only like,
You
Great.
can max it at 2 if you want to. That's the most I'm hoping for. If I
Okay.
get, if you come by this classroom later and there's still 2 there, you'll be like, yep, that's right.
all right, sounds good. Yeah, and I'll be emailing them out too, so no biggie, but
I can even go over to my little attendance sheet and point out which ones are definitely not gonna be here.
yeah.
Yeah.
Hopefully, we'll get more. We'll get more.
It always starts strong and ends up with, this is actually pretty good. This is, I'm pretty happy about this. Usually it's 1 or 2 on the last day.
Yeah, we'll have to. Well, we'll see how next session is.
I always scare them enough, you know, it's fun.
Yeah, I know, and then now I'll start scaring them. I'm just kidding. And Ramiz, I emailed about I emailed the instructors.
Oh,
And so I'm still waiting to hear, so I'll let you know, okay? I haven't forgot about it. Okay, all right, well, unless you guys have any questions, you can head out, okay? All right, thank you, Ben. Okay, have a good night.
See you later. Dun, 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 dun. I was hoping she'd turn around and make a comment about that, but thought that'd be fun, you know? It's the little things in life. The little things in life, you know? One thing I will say is that I really wish I had used the whiteboard this whole damn class.
I'm just thinking this for Tuesday.
The reason I'm not is because for Zoom, when I hit share screen, if I just, let's see, let's stop the share. One, I don't really know how to mess with the camera, but I'm sure I can figure it out. And 2, I really hate the idea of pointing a camera at a screen. So the visualizer and the camera app is pretty awesome for people who, like, they have a rule of at least use a tablet or a laptop or a computer for connecting online. I'm not stupid. I know most of the people are just using their phones. If I'm on that, they can't see anything at all. So that's why I do this. But see, not a single person has used it online this entire time. This is the first time I've had an online component to a class and nobody's used it. Had I known that, I would never have opened Zoom. I would have just been doing this on the board. It's a little nicer that way. But you know what? At this point, I've been doing it long enough, so I'm just gonna stick with that. Plus, I have been recording the last few classes, and most of them are on YouTube. So, if you ever want to see my inane rambling again, there it is. Oh man. 14 minutes in, I got that much soda left. So I should have brought 8. Should have brought 8 of them. No, it works. All right, well, nobody else is showing up. 14 minutes in. They already started that crap. So let's play this game. You guys ready for math? One more? One more. Let's do this. rocking mostly lines this time. We're doing lines in school. Yeah. Oh, yeah. So, reviewing some graphing points. Ooh, look at that point. Isn't it beautiful? It's on a graph. How exciting. All right. So again, in order to graph a point, you normally have it, it's actually called an ordered pair, is when you have it in a set of parentheses and the x comma y. So points are normally given to you as an ordered pair. We have 3, 4, which tells us we're going 3 in the x and 4 in the y. 3, 4. Look at that, it's exciting, it's a dot. It's a beautiful dot. We love that dot. And then expanding upon this, if we are given an equation of a line, and note that you always know if you have a line, if you have 2 variables, and none of them are squared or cubed or anything like that. If you do like a square, you end up getting a shape called a parabola. So we're not playing that game right now. So you always have 2 variables, doesn't matter what they actually are. And that's always going to give you a straight line. So you'll be able to plug in for 1, find what sticks out of it, and throw it at a table. It doesn't matter technically which one you plug in for, as long as you find the other one and put it in a table in order. So our table was basically a pile of ordered pairs. So in this case, we have 3 points. We take those 3 points and just like the last slide, we graph them along. Graph them along our graph. Graph them along our plane. There we go. That's the word I wanted. We have point 0, 1, 0 in the x, 1 in the y. -2, -3, back 2, down 3, and then 2, 5, over 2, up 5. Go. Pretty sure it's like English. Or writing. I'm math. I think they're English or it's a terrible language. I don't think anyone can really have to learn it.
Spelling and all that.
I before E except after C, except for, literally half of the situations that have INE in them. It's roughly about half. It's stupid. There are no solid rules. English is a mishmash of every other culture. It doesn't matter. Fun thing about garlic bread. Went to Walmart, got one of those loaves of garlic bread you can buy, throw it in the oven. Totally sliced it up and made burger buns out of it. You ever use garlic bread as a burger bun? Do it. The shit. Highly recommend doing that. Suddenly my world is easy. All right. We're starting off with y equals 4x. So we gotta graph that thing. And until the next section, we don't know how to do that by eyeballing it, but this would actually be a really easy problem to eyeball. So we need to pick some points. If you remember, my go-tos are usually -1, 0, and 1. Doesn't really matter what your go-tos are. I recommend keeping them small so your graph doesn't suck. You could always do it in tens and then count by tens in your graph and confuse your instructors. That's always a fun idea. But yeah, those are what I'm rolling with. So x is -1. Y is equal to 4 times -1. 4. Oh, I'm already failing at my job. Okay. Plugging in equals 0. I love plugging in 0. Because 0 times anything is 0. Love it. Best point ever. Where is that on the plane? Right smack dab in the middle. X is 1. Y equals 4 times 1. 4 times 1 is 4. Slap that on our graph. And now what we got to do is plot these points and see if they're along a straight line. Let's see, my y goes from -4 to 4. Louder this time than it usually is. Some thoughts are trying to win out. My initial thought is to break out the E-Man What's Going On video on YouTube. Just let that go. Might do it when I leave, just put on the 10-hour version, keep the volume at 100 and leave. Yep. There we go. I think that could be fun. Okay, well, that kind of helped a little bit. Now it just sounds muffled. Somebody covered the voice with a pillow, which is exactly what I'd like to do. Okay. So you have point -1, -4. That's -1 on the x, -4 on the y. And again, going ahead and labeling our points is useful at this point. 0, 0. Smack dab in the middle, 0 in either direction. And then 1, 4, 1 in the x, 4 in the y. Right up here. 1, 4. Look, say, are those along a straight line? Yeah, they look like it. There we go. We have a graph. Isn't it beautiful? So beautiful. You know, it kind of is. Usually they kind of look like butt. So I'll take it. What else we got? Y equals 1/3 x minus 4. Shows up. I even wear the name tag. I usually only wear the name tag the first day. I didn't even know it existed for like the first 6 months it did. It was just sitting in my box in the office and I'm like, oh God, I never go in there. I literally just get told when my class is and I show up one day. Most of the time, I don't even go to the orientation. To be fair, those are usually during weekends. So. Again, it's a good idea to pick points that are gonna come out nicely. If we look at our equation here, we can tell that anything we plug in for x is gonna be multiplied by 1/3. So if I plug in a 1, I get a fraction. If I plug in a 2, I get a fraction. But if I plug in a 3, it goes in evenly. So you always want to plug in a multiple of that denominator right there, because that's gonna make your life easier. Now, to be fair, when we cover the next section, you're probably never gonna draw a straight line quite like this again. But for future lessons, for future topics, like when you're doing, say, x squares, x cubes, when you get higher up in there, it's very, very useful because, like I've said before, you are gonna always go back to plotting points. When you have something ugly, it's kind of your standard fallback. So I'm gonna plug in multiples of 3. I'm thinking -3, 0, and 3, just to stay consistent with my usual. Why not? So if x was -3, then y is equal to 1/3 of -3 minus 4. 1/3 of -3, -1, minus 4 gives us a -5. When x is 0, x is 0, the thing that is getting multiplied just drops off. So the only thing left here is that negative. X is 3. Y is equal to 1/3 of 3 minus 1/3 of 3, 1, minus 4, -3. Gotta love it. Look at those. Those are all pretty close together. Now, one thing you're gonna note is that if you notice when we had 4x, that sucker was steep. We got 1/3 x. This guy is gonna be the other way around. It is going to be very gradual. So my x's go from -3 to 3. My y's, well, they're all in negatives. So x is -3, y is -5. 1, 2, 3. 1, 2, 3, 4, 5. That's another reason I like just making my graphs based on what numbers I have. It's just because, oh, where is this one going to be? Literally my corner, because that's as far out as I cared to go. So -3, -5, 0 and -4. So 0 in the x, -4 in the y. And then 3, -3. So 3 in the x, -3 in the y. Yep, those are definitely along a straight line. So when we have a fractional number attached to that x, it's a lot more gradual. Whereas when you have a larger number, it's a lot more steep. And that factors into literally the next thing I'm going to cover, but that's going to be after the next two problems, which will totally fit at the bottom. Shush. So these two are a little funkier because we don't have two variables on either one. I always like to demonstrate what happens there with XY charts, because that doesn't mean that we don't have the other axis. That just means that we have one constraint on it. And, you know, in this case, it's clearly defining what X is. So it doesn't matter what Y is. Y could be -1, Y could be 0, Y could be 1, Y could be 500. I don't care. What is X? It's 5 for every single one of those. Now, if you take a couple of those options and you decided to plot them, well, where do I need to be in X? 1, 2, 3, 4, 5. And at that point, it doesn't matter what Y is. When Y was -1, my X was 5. 5 and 0, 5 and 1. It'll work for all of them. Up here, down here, doesn't quite matter, because X is equal to 5. Anytime you have an X equals, it gives you a vertical line. Because it's telling you for every single Y value, X is 5. And the other thing, other way around happens when we have this Y equals 2. Doesn't matter what X is, Y is always going to be 2. So if X was -1, Y is 2. If X is 0, Y is 2. X is 1, Y is 2. Y is always going to be 2. Because anytime you have a Y equals, you end up with a horizontal line. Once you do 1,000 of these, you'll be able to just be like, oh, I have X equals 5, whatever, go out to 5, boom. Oh, I have Y equals 2, go up to 2, boom. But say that you're sitting in a test, you know it's going to be a straight line, you don't remember which one. How do you go about figuring it out? Make one of these guys. You don't know, then you can absolutely take what you know and build something out of it. Good stuff. We happy? You guys like graphing with points? Ready to make it worse? Oh, hey, I missed one. Yeah, whatever. It don't matter. God, I'm terrible at the job. All right. Hey, look, slope. Slope is a thing. So this is going into more of how lines are actually structured. We know that the X's and Y's will relate to each other by giving us kind of a path. But the slope is actually kind of what I was referring to on the last couple of problems, where it tells you kind of how steep your line is going to be. You can actually, using the slope, you can actually eyeball your graphs, which is great. Love it. Now this looks confusing as hell, but it's really not. The idea behind this formula here is that it is relating 2 points, any 2 points, because any 2 points can give you a line. And out of any of those 2 points, you can draw them at this little formula and you will get what's called the slope. And that will tell you essentially the steepness of the line you're working with. And that'll be the same across any points along that line. You can actually do this equation backwards between two different points. You can do it with one of them first and the other one first. Just separately, you will always end up with the same number. You can pick something where x is 500 and x is negative 3,000. Put them together, you will get the same slope if you use where x is 1 and x is 2. Always. So what we're going to do is we're going to work with two separate points, and the idea here is that those little sub 1s and sub 2s are just referring to which point they're coming from. So we have one point where it's an xy and another point where it's an xy, but they're both x and they're both y, so how are we going to differentiate the two? You call 1.1, you call 1.2, call it good. So that's all that's really telling you is that, hey, these ones are off of the same point, and these ones are off of the same point. So as long as you keep that straight, it doesn't matter which point is which, it's always going to work out the same. Now, one of the useful thoughts about slope is that you can refer to it as rise over run, because on our formula, we have the difference in y values, which is the difference in height between 2 points. So that's a rise between 2 points. And on the denominator, we have a difference in x's. So that would be the difference in width between 2 points, or the run between 2 points. So you always kind of consider it rise over run, because honestly, that's the easiest way to refer to it. And it sticks in your head if you keep saying rise over run. It's just a nice little way of doing it. Now, this usually scares the crap out of people, but this is one entire problem worked out. So that's every step you might do, and one of them is kind of pointless. So if we rolled with our example of y is equal to 2x plus 1, and you took two of the points, we have -2, -3, and 2, 5. And it doesn't matter which one's which, but in this case, we're going to say, okay, well, this one's point number 1, and this one's point number 2, just because one of them you see first, one of them you see second. Why not? So at that point, we're going to use this equation, and you would say, okay, we have y2 minus y1. You say, okay, well, our y2 is 5, our y1 is -3, so we'll have 5 minus -3. x2 minus x1, that's the x value from the point we started with, minus the x value on the other one, 2 minus a -2. Okay, well, at that point, we have 2 minus a negatives, so that would just change our signs to a plus. So that's all this next step was. So 5 minus a -3 is 5 plus 3, which is an 8. 2 minus a -2 is 2 plus 2, which is 4. You have 8 divided by 4, which is 2. Now, that's more of a proof of that working for that problem than anything, because at the end of the day, you can actually just see the slope if you look at the equation. And this is why I always solve these things for y equals, because this is the form I prefer to work with lines in. It's called the slope-intercept form. And the slope-intercept form is written y equals mx plus b. And the y and the x are pretty much just left alone. They're your variables. So the only things you need to define a line are the m and the b. The m is the slope. The b is the y value of the y-intercept. And that's just the point that crosses over the y-axis. And why is it the y value? Because the x value on the y-axis is always there. So I always like to point out that most of the time, if you have to find the y-intercept, you might be like, oh, the y-intercept is 3 or something like that. Technically, it would still be an ordered pair where x is 0 and y is that 3. A lot of times you can get away with not thinking of it that way, but just in case, that is the idea. So let's actually play with a few of these. And no, I don't intend to do all 10. That's a lot. I don't want to deal with that. You don't want to deal with that. Let's not deal with that. Let's deal with number 1. With -3, 2, and 2, 5. So we use our formula, which is m is equal to y2 minus y1 over x2 minus x1. And again, it doesn't matter which one's which, as long as if I start with one point on top, I gotta start with that same point on the bottom. I don't care. Because both of these are x's and y's. So we could just be like, oh yeah, this is point 1, this is point 2. Yay, we're happy. Okay. So we're just gonna set it up that way. This y minus that y over this y, or this x, minus that x. We have minus a negative happening down here on the bottom, so we can change that to a plus. On top, 5 minus 2, 3. On the bottom, 2 plus 3, 5. Cool, we're done. If you can reduce at this point, do it, but it's not always going to happen. But yeah, that's the slope. Horrifying? Terrible? Okay, excellent. Let's do a couple more just for fun. I'm having fun. Are you guys having fun? Yeah, okay. You better. If not, I'll start screeching like a little girl. That's fair. Always tell people I've been tutoring and teaching since 2008, and I've only met literally a couple of people that I would say are beyond help. Literally a couple. If anyone says no one's beyond help, they're lying to you. There's a few, but it's usually the ones that don't care. I had one student who had trouble even adding, and he was in shop math, which is horrifying, like trigonometry puzzles. Most of us in the tutoring center had already taken like Calc 2 by this point, and we were just staring at his problems like, what? They were horrible. And I'm like, how the hell is this guy gonna get through them? He came in day in, day out. Drove us freaking crazy. Day in, day out. He didn't just do his homework. He did every problem in that damn book. Every single one. And he got a B at the end of that class. And I respect the hell out of that B more than anybody that probably pulled off an A. Because, damn, I have never seen anybody that determined. I don't think I ever will again. That was impressive. It was terrifying. I couldn't have pulled that off. I would have quit. I'm not gonna lie. All right, so let's do another. Now this one, I can already tell that whole subtracting a negative would happen. So what I'm gonna do is I'm gonna start with this point. I'm not gonna label them as x1, y1, x2, y2. I don't care. All I need to know is that I'm subtracting y's on top, subtracting x's on the bottom. And if I start with one point on top, I gotta start with that point on the bottom. So if I do this y minus that y, I gotta start with this one on the bottom. This x minus that x. Okay. We get -6 over -8. The negatives will cancel out right away, right? 6/8, 2 goes into each of those. 2 goes into 6 3 times, and 2 goes into 8 4 times. Now, again, like I said, it's not gonna matter which way I do this. I can pick either point to start with. It doesn't matter. If I had gone the other way, I would have ended up with this, which would have given me 3 plus 3, 4 plus 4. I would have gotten that 6/8, and the only difference would have been the signs. So the only thing that can change if I pick one point versus the other point is the signs. You're gonna get the signs the other way around, and they're just gonna cancel out. So any 2 points across the line will always give you the same slope. How are we feeling about plugging into that thing? Doable? Not doable? Slightly dead inside? Do one more of those, make it number 3. 7, 3. And 6, -1. I think I had a mini stroke when I was writing that 6. These things happen. Sometimes those neurons just misfire. Okay, and same idea. It's always y minus y over x minus x. So say I started with this one. This y minus that y. -1 minus 3. I started over here, so I got to start over here on the bottom. 6 minus 7. I get a -4 over a -1. -4 divided by a -1. Negatives cancel. We just get a +4. All right, so that's how to compute a slope. You know how to recognize a slope right away? All goes back to that form. Remember, y equals mx plus b. That sucker's important. You are going to use it for the rest of the time you ever do anything math related. That is just gonna pop up here and there. So y equals mx plus b, the thing that's the slope is always attached to the x when you have y equals. So just looking at 7 through 9. On 7, we have a 3 multiplied onto the x. So the slope there, 3. Number 8, we have a 2 multiplied on the x. The slope there, 2. Number 9, slope is -1/2. Those ones are easy, right? But what about the other ones? How do you get the slope on those? Well, we have 2x plus y is equal to 2. All you have to do is make this fit our standard formula. Y equals mx plus b. So we need the y alone. Okay, well, that just means I gotta subtract the 2x over here. So I'll have y is equal to, and then I could write 2 minus 2x, but since having the x term first would fit our formula better, I'm gonna write minus 2x plus 2. And that's why on some of the problems in the previous class, I had written them with the x term first, because that sucker. Okay, what's our slope? -2. Effort. So if it's not in slope intercept form, you just solve for y and find the slope from there. You had one more like that. That was 3x plus 6y is 18. So on that one, exact same thing. We need to solve for y. So let's subtract 3x both sides. We'll have 6y left on the left. -3x plus 18 on the right. And then when I divide by that 6, I'm going to divide every single term by 6, which is kind of annoying sometimes. It's not too bad here. So -3 divided by 6 is a fraction. You can just reduce that. 3 goes into 6 twice. So this is -1/2 x. And we can just pull the x out. This could also be written as -x/2. That's kind of weird. I always like to pull the x out, so it's over here. 18 divided by 6, 3. But really, I don't really care if that's 3, because I'm only after the slope. Is -1/2. That's a slope. You guys like the slope? Yeah, you do. You do. You're excited. Yeah, you're so excited. Calm down. Well, everybody relax. Nice and happy. All right. So we've now looked at the slope intercept form. We have played around with what the slope is. Now we're going to actually use the slope intercept form. So this is my preferred way of actually graphing lines because I don't have to make a chart. And as long as something is in the slope intercept form, I can just eyeball the problem, which is great. Big fan of minimal effort. Yeah, might as well. Start again now. Wait for it. It'll happen. Guaranteed. They're over there in the All right. So using the slope intercept form. So you can get all of the necessary information to graph a line just looking at a formula in that form. Very convenient. All you really need is the slope and the y-intercept. And what you do is you basically say, okay, that y-intercept, that's the first known point on your line. So you can just draw your graph, put a dot on that point, just straight from the equation. You don't actually need to go to any trouble. And then the slope is coming off from that point. You find the next point based on what your slope is. And that's why I said slope you consider rise over run, because from that point, you're going to go rise and run. And it's great. Very easy. And the nice thing is that even if your graph is horribly jank, you might end up with a zigzaggy line, but it'll be accurate. And that's my favorite part, is having it accurate, even if it looks terrible. The best. Well, we've already done this, but converting equations to slope intercept, you just solve for y equals, put the term with the x first, and you're good. We already did that. Let's not worry about that. This cracked me up. I want it to be real. I'm sure it's fake. Hi, how you doing? Is your father an astronaut? My father's dead. So was he an astronaut? Could you keep this out of this world? Good stuff, good stuff. The only thing that makes me think that it might be real is that status thing there, because that's a standard Facebook one, and if you reply to somebody who's not on your friends list, then it just unblocks them from not talking to you further. I know it very well because I have made many people angry on the internet. It's every once in a while I get somebody sending me just really messed up messages. Am I offended? No, I mess with them. I torture them a little bit. And then I post screenshots of it to my Facebook so other people can laugh at it. Love it every time. I look forward to it happening every year. So every one of these, you're going to graph using the slope intercept form. And for the most part, yeah, we could actually take care of all of these in the time it took us to maybe graph 2 of them before. So I have 2x plus y is equal to 2. And every single one of these, the most important thing is that it's in our correct form. So we solve for y by subtracting 2x over it. I have y is equal to negative 2x plus 2. So now we got a graph using this. So you start noticing what happens when you have different slopes. Like I said before, if it was a fractional one, those are pretty gradual. They're pretty, pretty flat. They're flatter than if I have a larger number. Like when we had 4, it looked like that. But this guy is negative. What happens in the negative slope? Well, negative slopes always push your graph downward. So it's going to be facing this direction. So let's start this off. Our y-intercept is +2, which literally just means we go up to 2 and draw a dot. Now these ones, to be fair, I don't know exactly where I need my graph to go out. So I usually just prepare some points. Now, from here, we're going to use our slope. Well, how am I going to do that? Our slope, in this case, is that -2. So what you want to do is think of this as a fraction. Now, it's not a fraction, so if we put it over 1, then we could very more clearly see a rise and a run. And that's what we need from the slope. That's the important bit that we want to work with, is getting our slope and determining a rise and determining a run. And that's going to be the difference between every point along this line. What does a -2 rise mean? It means we're going down 2. So from that point, we go down 2. All right, we're on the axis. What do we do now? 1 run. So that's 1 in the x direction. Over here. Down 2 over 1, we draw our point. And all of our points are going to be following that direction. Down 2 over 1. Down 2 over 1. Look at that. We already got 4 points. That's more than we did on any of the other graphs. You can also kind of reverse the signs on your fraction, because this is certainly equal to that. You can go the opposite direction. You can go, once we know we're going down 2 and over 1 to the right, we can certainly go up 2 and back 1. And that'll also work. Up 2, back 1. I got 6 freaking points on that line. If I draw a line between them, it looks like garbage, but you know what? It's a line. Like I said, we have a negative slope, it's going down. But not bad, right? It's actually pretty useful. Look at another. Y equals 3x minus 2. It's already in our slope intercept form, so we don't got to play with things. And then instead of writing the slope outright, I'm just going to look at this and say, okay, over 1. There we go, effort. Always keep that rise over run rule in mind. So our y-intercept is -2, which means we're down at -2, and that's our first point. Now, our slope is a positive number, which means this thing's going to be going up. So luckily, I didn't waste this space. Let's get a couple of points worth of space here. Okay, so again, think of it as rise over run. Rise 3, run 1 from that point. Rise 3, run 1. Rise 3, run 1. There we go. That's all we need. Now you might say, hey, can I just stop at that second one? I mean, yeah. I would recommend having a ruler so your line doesn't, start going off into some other direction. That's why I usually do a bunch of points on these ones just to keep it straight. Because honestly, I'm terrible at making graphs. They look like garbage. But that's it. They're not too bad. I'm not gonna do 3. I don't know why I did that. Let's do 4. I like 4. Y equals -1/2 x. You know what? Let's just leave it -1/2 x. I don't know why I got so many y-intercepts of 2's. So, well, make it not look awful. Y equal to -1/2 x. We're just going to do it that way. Now, the reason I want to do it this way is because there's a couple of different quirks to these types of problems that this demonstrates. One, we don't have a y-intercept. There's nothing else there. I got puppies. So there's no y-intercept. 2, we have a negative in front of the fraction. Where does that negative go? What do we do with it? Something's going downwards, but where am I going to consider it? Is it part of the rise? Is it part of the run? That's the one I want to address first. We can tell that our slope is -1/2. But the problem there is how to interpret this for a graph. And the thing is, when we have a negative on a fraction, we can interpret it 2 different ways. Well, I guess 3 different ways if you include that initial one. It can go on the top or it could go on the bottom. Either way, in this case, I have a negative divided by a positive, so this whole term is negative. Here we have a positive divided by a negative, so this whole term is negative. All of these are equivalent. That's why this works out that way. So when it comes time for us to graph this guy, we have to kind of pick one of these that we're going to roll them, right? And usually kind of a decent rule of thumb is just take that negative and consider it part of the top. gonna make life easier because we're just used to graphing from left to right, right? We're used to drawing a point and then moving over to the right and drawing the next point, and moving over to the right and drawing the next point. So if I do it that way, my run is positive, which means I'm gonna be moving to the right, and it's gonna be a little easier to process. Is it necessary? No, but it's just a decent way to go. So the other point, where is my y-intercept? We got our M, we don't got a B. But if I had to, I would say there's nothing there. That's exactly how we interpret that. We say, oh, there's nothing there. So that means our y-intercept has to be 0. There isn't one, so it's just gonna go right at the 0. Which tells us that our graph goes right through the origin. So, starting from that point, I'm going to go with this. I'm going to view this as my rise, and this is my run. I'm going to go down 1 and over 2. Down 1, over 2. Down 1, over 2. I could also go up 1, back 2, so the opposite direction. And that's literally what's happening here. Rise 1, run -2 would be going back 2. All right, there's 4 points. They're all along a straight line. And there we go. That's about as complicated as they could get, right? Now, one thing I would like to address, I don't know if I have an example of it. No, I don't. Okay. One thing I would like to address is if we go back to the review problems, when I had the vertical and horizontal lines, and I said, hey, what's my slope? Because even though these are not in our standard form, there is something we can say about the slope. And a lot of times when you're learning about slope, you will be asked about it on vertical and horizontal lines. They just want to make sure that you understand the concept. So what I like to do is I like to explain these as just immediately thinking of slope as rise over run and kind of pulling that out of my graph. Because when it comes to x equals, what's the rise between any 2 points? I mean, it just depends on how far apart they are, right? Like the rise between this point and this point is going to be the rise, it's going to be different than the rise between this point and this point. But we know it exists. But say I started all the way down here at like -1 billion, I went to the one up here at +1 billion. It's suddenly 2 billion, right? So what I kind of do is I kind of say, oh, well, could be everything. It could be infinity. But what's my run? I don't have one. It's not going anywhere to the left or the right. So I'm dividing by 0. Can I divide by 0? Oh God, no. The world blows up. You just blew a hole in the universe. So what we do when we have a vertical line, we say slope is undefined. We might also say there is no slope. It can't exist, which is different than saying 0. 0 is a number on your number line. Not existing, that's not, right? Now, you might be able to see what's going to happen with the horizontal line. With its rise over run, In the case of this one, you have 0 rise and you have whatever for the run, right? Well, 0 divided by anything is 0, right? Which makes sense because there is no slope between two of these points. But as a slope, if you had like a flat cliff in front of you, yeah, that's an infinite slope. That's just going straight down, you know? There's not exactly something happening there. So you would say that all horizontal lines have a slope of 0. So you literally just think, oh, rise over run. Do I have a rise? In that fraction of rise over run, where is my 0 going to be? If I'm dividing by 0, can't exist. If I have 0 divided by something, that can't exist. It's just nothing. Okay, guys, I only have another 110 slides. We're gonna stick with it till the end, right? All night. We're just gonna be here all night. Actually, we're gonna be here until 3 in the morning, specifically. Because I am waiting for a product to launch at 3 a.m. I like those little emulator handhelds, you know? Somebody's gonna make a freaking SP looking one. And I'm gonna buy it and I'm gonna load it full of games. And it is going to be exactly as the one that I gave to my girlfriend in a different shape, but you know what, I don't care, I'm gonna throw my money at them. The best part is the freaking price. These, honestly, most of them are pretty cheap. If you just want to go up to PS1, they're stupid cheap. Love it. You want to do past PS1? Nah, that sucks. Suddenly you're jumping a lot higher. All right. That's how we play it with equations of lines. We can now plot points and draw a line between them. We can look at the slope and the y-intercept and take those informations and make a line out of those. But the one thing we're missing is, well, what if I don't have the equation of a line in the first place? Go close together. There we go. Don't know what's happening there. Paragraph spacing is weird. So you can actually take information about a line and make an equation out of it. There's 2 different methods of doing it. I'm particularly picky and I usually just teach the one I learned. I'll explain the other option, but I don't like it as much. Literally, oh God. Okay, so, okay, yeah, we're going. Yeah, body, just see a hand reaching. Correct. So, finding the equation of a line. In order to find a line, all we really need is 2 points, right? Because a line is 2 points. Also, to find a line, we just figured out we can get away with a slope and a single point on our line. Now, granted, that point was the y-intercept, but we can actually do it with a slope and any point. Be done. Works out great. Love it. So our standard form of the lines that we're using right now are y equals mx plus b. But in terms of algebra, we've already played around with a little bit of that, and we've said, okay, well, if I have all but one of my variables, I can find the other one. So if I have the y, the m, and the x, I can find the b. If I have the y, the x, and the b, I can find the m. All you need are a couple of pieces of information, and we can throw them at a point. So if you are given 2 points, you can find that slope, and there's a way to find the y-intercept. If you're given a slope and a point, there's specifically a formula that we have that we can use. And it looks like this guy. Now, the interesting thing about this guy is that if I took both sides and I divided by this thing, it would just be the formula for a slope. It would be m is equal to y minus y over x minus x. The same formula, just in a different way. And the idea here is that the y and the x that don't have a 1 on them, they just stay y and x. You just leave those alone. What you need for this formula is a slope and any point along that line. You clean it up and you always end up with a perfect equation of a line every time, no exceptions. Now, you might say, okay, well, if I have a slope and a point, that's all well and good, but what do I do if I don't have a slope and a point? What if I don't have the slope? What if I have 2 points? If you have 2 points, we've already figured out how to find the slope between them. So then you can just find the slope, and you can use this formula. Now, I don't think, yeah. For some reason, I decided to combine this lesson with another concept, and we're going to see how it works. Crash course, why not? Let's see what happens. We also have the concept of parallel and perpendicular lines. So these we haven't played around with, but the general idea is it's relating to slopes. If 2 lines are running across, like along each other, but they never cross each other, they're parallel, right? But in order for them to be parallel, their slopes have to equal each other. So any 2 equations that you see that have the same slope, those are going to be parallel lines, whether you graph them or not. Straight away, they're parallel. Now, if they form a right angle, that's referred to as perpendicular. And perpendicular is a little funky. In order to find a perpendicular line, you actually have what's called the negative reciprocal of that slope. And I'll show you what to do when we get to that. It's going to be in one of these problems. That's very accurate. Saw is unrealistic. No one has that much will to live. I'm not sawing off my leg. I don't care. You're gonna die. I'm gonna die if I saw off my leg. Freaking kill me, dude. Let's see this.
You can jump into this pool of eagles.
No, thanks. No, I'm good. Do what you gotta do. Not gonna happen. How long are the needles? That's an important question. Are they a 1/4 inch? Then it's gonna suck. That's like falling onto like a really bad sticker bush. Really sucks. Are they 3 inches long? We're not doing that. We are not doing that. That's not happening. All right. So number 1 says, find the equation of a line that passes through these points. -2, 4, and 1, 2. So the things that we're going to need are the slope formula, If I multiplied both sides by this thing on the bottom, I would end up with something that looks like this. And that is the point slope formula. So called because I need a point and I need a slope. Effort. So I got 2 points. I need a slope. What's my slope? Hell if I know. Let's find it. So we pick a point to start with. Let's say I'm starting with this one. We're do y minus y, so 2 minus 4, over x minus x, so 1 minus a negative 2. When I subtract that negative, it turns into a plus. I end up with a negative 2 on top and a positive 3 on the bottom. Cool. There's a slope. Lovely. All kinds of happy about that. All right. Well, we have our slope, so we have 2 points. How do I plug that into the point slope? Does it matter which point I pick? No, not even a little. Just like picking a point for the slope doesn't matter. As long as it's along that line, you can pick any point. So what I usually recommend is picking the one that's going to be easiest to plug in. This one has bigger numbers and a negative. That introduces the possibility of making a sign error. So I'm going to try to avoid that. This one is nice and neat and little. There's also going to be multiplication involved. We have an m multiplied onto that thing. So I'm going to try to keep the numbers small, particularly the x, because that is going to be distributed in. So if my x is really small, that's going to make my life easier. I'm going to have to multiply by a fraction sometimes. So that's the point I'm going to use. We're going to do y minus our y1, which is 2, equals m, which is negative 2/3, parentheses, x minus our x value is 1. And once we clean that up, we will have our line. So what does the line look like? Well, we normally have it y equals, right? So let's shoot for that. First thing you have to do is deal with distribution, because I can't exactly deal with this minus 2 yet. So I have negative 2/3 times x. That one's easy. And then negative 2/3 times a negative 1. Luckily, that one's also easy, because the only thing that's going to change is the sign. So we get a plus 2/3. Now, the only real downside of dealing with these types of problems is the fact that a lot of times you're going to end up with fractions and having to combine things with fractions. So that goes back to adding 2 numbers together. Usually I just kind of use the margin of whatever it is I'm working on. And I'll add that over there. If I'm adding fractions, I put this over 1, so it's a fraction. I need a common denominator, which will be 3. So I'm going to multiply that by 3 over 3. 2/3 plus 6/3 gives us 8/3. Is it pretty? No, but it's a number, and I'm cool with that. So it's y equals negative 2/3 x plus 8/3. Nothing wrong with just taking your ugly part and moving it over here. And we have found a line in y equals mx plus b form. I could graph that if I didn't hate the idea so much. Yeah, just start at 8/3. It's great. Yeah, not too bad, right? No, I'm not going to graph that at all. But that's how you'd work those out. All right. I Let's play with more. So number 2 is a very interesting question. What is the line that is perpendicular to the line that connects -5, -6, and 10, 3, which passes through 0, 2? The hell does that mean? So there, usually when you learn parallel and perpendicular and you're putting lines together and everything, you're usually given weird problems like this. And to be fair, they're usually this is at the end of the lesson, this is where everybody's gonna give up, so slam them on there, right? But they're honestly not as bad as you would think. Because the main things to understand are, we are looking for a line that is perpendicular, and that line passes through this. So the idea here is that we need something, let's say these particular points, they're not going to, but let's just say they go through something like that. Let's say they're like that. And we have some point, let's say our 0, 2 is right there. I don't care. In order to make a perpendicular line to this, it has to have a right angle right there. Has to be perfect right angle. So that's where the perpendicular comes in, is there's rules to make that. So the only thing that applies to is the slope. So the idea is that we are going to take these 2 points, find the slope between them, and we are going to find the negative reciprocal of that slope. That sounds really fancy, but it's really not. So first thing we got to do is we're saying these 2 points are along a different line. So we got to figure out what the slope is on that one. And it's going to go the same way that all these other problems do. Y minus y, -6 minus 3 over x minus x, -5 minus 10. Okay, I get -9 over -15. The negatives cancel out. 3 goes into here 3 times, and 3 goes into here 5 times. Okay, I got 3/5. What is that? What's that good for? Well, that's the slope of, say, this line, but we want that one. So we find the negative reciprocal. Now, the nice thing is that the perpendicular slope is incredibly easy to find. We literally take whatever we had here, flip it upside down, and slap a sign change on it. That's it. That's our slope. We like it. That is straight up it. You just flip it upside down and change the sign. So that is guaranteed to be the slope of this line. Okay. Now what do I do with that? Well, I have the slope of the line we care about. Now, none of this matters. We know it's going to be perpendicular to this. We already got the slope there. We flipped it upside down, changed the sign. That's what we needed. Now all we need is our line. We have a slope, we have a point. So we use that formula. Again, y minus y1 is equal to m x minus x1. Okay. That's the point we're using. So we're going to do y minus 2 is equal to our m is -5/3 x minus the x value. Oh, it's a 0. Love it. Effort. That makes distribution easy. It's just going onto that one because when it multiplies over here, that's nothing. So this ends up being -5/3 x, and then that thing multiplied onto 0 is gone. All I have to do is add the 2 over. I have y is equal to -5/3 x plus 2. Isn't that fun? I know it's a horrible one. Why the hell did I write it that way? I don't know. I just thought about introducing that and crammed it into some problems. Why did I do it that way? Usually this would be one of those concepts where I'm like, okay, I see how people are reacting. I'm going to refine it for the next class. But I'm not going to have a next one. I might still have a next one. I don't remember her name. I don't know for sure if she was their math teacher. So I was taking a lot of notes. Huh? Huh. It's teaching style. Teaching is definitely its own skill. You definitely learn that when you have a crappy teacher who clearly knows what they're doing and they have no idea how to help you. It's really depressing. I've had that multiple times. Right, so the next one says write a line parallel to the line that connects 7, 3, and 6, 1. Or 6, -1. Y-intercept of 2. Now this problem is going to be monumentally easier than the last one. I absolutely should have had this one as number 2 and that one as number 3. Because it is going to be parallel to this line, but it's going to have this y-intercept. So if you think about it, when we set up our formulas, when we set up our lines, we have y equals mx plus b. We have a slope, we have a y-intercept. If it's parallel to this line, that means it has the same slope. If it has the same slope and we're already given our y-intercept, all we need is the slope here, and we can throw the 2 in for that b, for whatever that slope is for that m, and we already have our formula. We don't have to put it into that other one. Great. So we find our slope. Y minus y, -1 minus 3, over x minus x, 6 minus 7. We have -4 over a -1 is a +4. We take that and we're going to just throw it at that formula. We know that the slope between these two points was 4. So the slope on our parallel line is also going to be 4. And we know our y-intercept is 2. That's the b. We put our 2 there. That's our line. That's about as easy as that can get, which is great. So parallel line, same slope. Perpendicular line, negative flipped slope. What if you have a solid number? Just like fractions, you put it over 1 and flip it upside down. How are we feeling? You guys done with life? Excited. Welcome back, RoboCop. RoboCop 1, truly messed up. RoboCop 2, uh-oh, we accidentally appealed to children too much. Love it.
Switch them.
Oops.
I've seen the new RoboCop.
I haven't seen it either, but I saw a few clips of it. They take it way too seriously. Which it should be. I mean, at the end of the day, as cheesy as RoboCop was, it was a commentary on the corporate police state. I believe the new one was, let's make a cool action movie. And to be fair, I like the actor they got for Joel Kinnaman. Been in a lot of things. This very cyberpunky show on Netflix, Altered Carbon. He was the main character in the first season of Altered Carbon. That was awesome. I wish they hadn't canceled it, but it's Netflix and they cancel everything. Anything that's good. Like Santa Clarita Diet, I'm always going to be mad at them. It's a wonderful show where Drew Barrymore turns into a zombie and literally starts eating people. At one point, they literally just have a guy's head in the basement and they accidentally had zombified him. So it's like, oh yeah, oh my God, I'm sorry. We tried to dispose of your body and we didn't know you'd still be alive, kind of. You've just been hanging out in the desert for months. So they just take his head and put it in a flower pot and talk to him all here and there. I don't know. It was great. Ellen actually made it to like 3 seasons. She accidentally kind of started a cult because she was immortal. The zombie.
Is it still on Netflix?
It is still on there. It is still on there. It is freaking great. It's a comedy where people die a lot, and that's just up my alley. All right. Next one. Let's make it worse. I know you guys liked inequalities. So let's do them with X's and Y's. Isn't that great? So the inequalities we did last time dealt with number lines. It's a range. It's always a range of left or right. But what do you do with an inequality when you have an X and a Y? Well, it's still a range, but it's like taking a sheet of paper, drawing a line across it, and saying, okay, pick a side of that line. That's really what you got going on. So what you do is you graph it as if it was just any regular line. You can use points, you can use slope and intercept, you can do whatever you want. Just make the line appear. And then what you do is you determine which side of that line is going to be correct for that equation. There's a couple of cheap rules here or there. Usually, the greater than equations, you end up shading above the line, and the less than equations, you shade below the line. I'm really big on just making sure though, because to be fair, I haven't paid attention as to whether or not there are exceptions to that. So I always like to make sure. Now, strict inequalities, the ones that don't have the bar underneath, just like number lines. If they don't have the bar underneath, it can include that point. Normally we would do an open circle, but we can't do that on a line. So what we do with lines is that we just make them dashed. So if it doesn't include the other side, we do a dashed line. If it can include along that line, we just do a solid line. So if you got the bar underneath, solid. No bar underneath, dashed line. Yay, dashed lines right there. Okay. The perfect meme. Mm-hmm. Yeah, that's how math works. You decide you're gonna make it worse. What did we? Let's go back here. What did we do over here? I don't remember. For the record, they cremated OJ. I'm mad. Could have been what I like to refer to as a gender neutral bathroom. Also known as a Confederate cemetery. Well, I mean, back here, class 3, we were doing unit rates and proportions. And prime factors, look at that. Oh my God, that was a while ago. That was a little easier.
This seems so easy.
Yeah, doesn't it? It seems, oh God, so much of this. Well, maybe not that sometimes, but so much of this seems so much easier than what we've gotten to working with. What's the percentage? Great, love it. Let's play with linear inequalities. It always gets worse, and you go back to the earlier stuff and you're like, damn, I wish I was still doing that because I was struggling through that and now it's not too bad. Let's struggle through this. Like I was telling somebody the other day, the best way to learn what sticks in your head, things that matter, evolutionary wise. If you're trying to learn something, it has to be a harsh lesson to stick with you. If everything's easy, it doesn't stick because it's not something that you need to learn from. So I like to add my classes to have at least a little bit of suffering. You got to suffer through it because then it might stick. Then your brain might be like, oh crap, I'm going to need this. That's my attempt at attaching evolutionary theory to teaching math. So far, so good. Seems to be working. All right, we got that thing. Isn't it beautiful? Cool. Now, how am I going to graph this? Let's do slope and intercept. That's my go-to. So again, we're just going to treat it like a straight line. We're just going to think of it as y equals mx plus b. We're not even going to worry about that inequality. We have our slope, we have our y-intercept, we have our rise, we have our run. So I'll draw a graph. We have our y-intercept is at 1. We're going to end up going up 2 and over 3. Let's be lazy about this. Up 2 over 3. There's our line. I'm just going to do 2 points effort, right? Now, this is where the sign matters. We have a less than, not a less than or equal to, which means we make a dotted line. Now, because this is an inequality, the values along the line don't make this true. The values on one side or the other make this equation true. So we need to say, hey, where is the y going to be less than that? Now, most of the time when I saw that for slope-intercept form, most of the time it's going to be, oh, is this less than? It's going to be down here. But I like to make sure. And the best way to make sure is to pick a test point. You just pick a point on either side of the line. Doesn't matter where, preferably something easy. I usually pick 0, 0 because, oh my God, effort. But you pick a point. Let's say for this example, we're going to use this point. Point x is 0, but y is -1. And that's going to be our test point. So for that test point, I'm going to do 0, -1. This is an x value. This is a y value. We are going to take those numbers and just plug them in and see what happens. So when x is 0, y is -1. So if I plug in -1 here, it's less than 2/3 of 0 plus 1 that thing goes away because it's multiplying onto 0. So if -1 is less than 1. Is that true? Yeah, right? -1 is smaller than 1. So because this point is true, that means anything on this side of the line that I plug into this formula is also going to be true. So the solution to this equation is actually everything on this line. So we, or on the side of this line. So we just shade that side. We say, okay, it's everything over there. Now, if I had picked something to test over here and plugged it in, I would have ended up with something that wasn't the case. I might have picked, say, something that would have given me, 5 is less than -2, and that wouldn't be the case. So if you find something that's incorrect, that means that whole side is incorrect, so the other side has to be. All right, let's suffer through another. This one, we have y is greater than or equal to. So the greater than or equal to tells me that that is going to be a solid line. -1/4 x plus 3. Now again, if I'm playing around with graphing, I'm usually going to take that negative symbol and I'm going to slap it up top. That's going to make my life easier. So that's my rise, that's my run, and that's my y-intercept. Let's graph it. My y-intercept is up here at 3. I'm going to go down 1 and over 4. Oh, we're going to have a wide boy. Down 1 over 4. Rise is -1, run is 4. And again, you can go the opposite direction. We can go up 1 and back 4. At that point, we have a nice line. It's going to be a solid line. And now we just need a test point. Always like to do a test point. In this case, we're just going to test 0, 0. That's going to make my life easy. You plug in 0, 0, everything's multiplied by 0. Effort. Now, one thing I will say is you never want to pick anything along that line because you are just going to get something that is equal to the other side because they're along that line. If we just graph this as if there's an equal sign, then everything along that line is going to give you two numbers that are equal to each other. So testing 0, 0, we have 0 is greater than or equal to -1/4 of 0 plus 3. So that part's gone. 0 is greater than or equal to 3. No, it's not, right? 0 isn't bigger than 3. If it was, I would be borrowing money from people all the time. Don't worry, I'll pay you back with 0. That's more. So this is not correct. So that didn't work out. So that means this whole side isn't going to work out, which tells me the other side will. Now, if you're still a little apprehensive about that, you can always just pick another point on that side of the line, plug it in, and verify that it gets true, but it will be true. No exceptions. Guaranteed. How do you feel about this method? You draw a line, you test point, you shade line. Not bad? Tolerable? Okay. I'm willing to skip the last two problems there. We definitely don't have time for more lesson. So the class is over. As is my teaching career. Potentially, I don't know. They'll probably ask me back. Or they'll have me tutor for them, or God knows. Who knows? I don't know. I like working in education. It clicks for me.
You're good at it.
The only thing I'm good at.
The good thing is